This video is going to be about solving logarithmic equations, and we're going to kind of do this in three parts. So we'll have three situations, and the situations I'm going to look at here is I'm going to look at what happens when you have one logarithm, and it's equal to another log. The second one will be what happens when there's just one logarithm in the problem. How do you solve that? And then the third one's going to look at how can properties of logarithms help us in our effort to solve equations. So those are going to be the three situations we look at. Try to do my best and hopefully help you out a little bit. So here we go. So situation number one, let's go with this equation. So we'll have the natural log of 3x minus 8 equals the natural log of x plus 6. And what we want to do is we want to take a look and recognize that, notice it's the same logarithm on both sides. This won't really work if you had different logarithms, like a natural log and a log base 10. But since you have a natural log on each side, and we want them to be equal, then all we really have to do is set the two parts that are inside equal to each other. So 3x minus 8 just has to equal x plus 6 for these two logarithms to be equal. And so we're going to set those equal since the bases are the same, and then we're just going to solve the equation that we're left with. So I'm going to subtract x. I'll have 2x minus 8 equals 6. I'll add 8 over. And so then we have 2x equals 14. I'm going to divide by 2. X equals 7. And I'd love to be able to say that you can mark that as your answer, but in logarithmic equations, you actually have to check this answer. You have to check for extraneous solutions. And so remember, that just means you have to plug it back into the original. And the way that what you're looking for is you're looking for that x value, does it make the inside of the logarithm 0 or negative? If it makes the inside of the logarithm 0 or negative, then you can't have that as an x value because we can't take the logarithm of 0 or a negative number. So 7 plus 6 is 13, so I'm good. And 3 times 7 is 21. 21 minus 8 is 13. So boom, I am okay. So you can circle that as your answer and call it a day for situation number 1. All right. Situation number 2, now you're only going to have one logarithm in the problem, right? That's what we said. Number 2. And so in situation number 2, let's take this one for example. This one seems good. Log base 3. And then inside the logarithm is x squared plus x plus 7. You're like, what the heck? Equals 3. And it looks like a terrible problem, but it's actually not that bad. So take a look at what we have. Since we only have one logarithm in the problem, there's not much you can do. You just have to make sure that the logarithm is alone. So you want to get the log alone, and honestly, it's already alone. Not sure how many problems you'll see where it's not alone, but if you see maybe like a +2 somewhere outside, or maybe you have like a 2 like that, you'll want to get rid of that. So anyway, by dividing, normal algebra stuff, but the stuff on the inside you can't touch, and so there's our logarithm by itself. So what we're going to do after we get the logarithm alone, second thing, we're going to rewrite the equation as an exponential. So remember, the way to do that is you want to start with the base. So the base is 3, and so the base of the exponential will be 3. you're going to raise it to the other side, so it'll get raised to the third power, and it equals what's on the inside. So x squared plus x plus 7, and then the rest is kind of just you being able to solve the problem. So 3 to the third is 27 equals x squared plus x plus 7. And if your nice math teacher asks you what kind of equation that is, you would say quadratic because it's got x squared. And the best way to solve a quadratic equation is by factoring. And then if factoring doesn't work, you just do another method like the quadratic formula or completing the square. So let's try to factor it. I'm going to subtract 27 so that it's set equal to 0. And I have 0 equals x squared plus x minus 20. Booyah, Grandma, that will definitely factor. So x plus 5, x minus 4. So x equals negative 5, and x equals 4. And so now you remember you got to check your answers. So when you plug them in, if it's going to make it equal a negative number, it's not going to work on the inside. So when I take negative 5, I plug it in. That's going to be positive 25 when I square it, minus 5, and then plus 7. So 25 minus 5 is 20, 27. I'm good. Plug in 4, that's 16, that's 20, that's 7, that's all good. All right, so both of them are good answers, and we're having a wonderful time. Circle them up. This is excellent. All right. Third and final situation. Third and final situation right now is how can I use properties of logarithms, and really this is going to kind of come into play when you're going to end up seeing like multiple logarithms in the problem, and you're trying to break it down to get to one logarithm. So take a look at this one. We have log base 3 of 3x, and then we have plus log base 3 of 2x plus 1, and that all equals 2. So if you want to end up rewriting this as an exponential, you're going to have to bring the two logarithms together. So in these kind of situations, what you're going to try to do is you're going to try to condense. Right? So if I see addition in the middle, that means I'm going to multiply the two things that are inside the logarithms. So that's going to be log base 3 of, and then that'd be 3x times 2x plus 1. I want to multiply those two things together. We should only have one logarithm, right, when we condense. That's going to equal 2. And now that I have one logarithm, it's kind of like situation number 2, where I'm just going to rewrite it as an exponential. So I'll have 3, that's the base, raised to the other side, squared. And then that equals 3x times 2x plus 1. And now you just have an equation that you can solve. So the first thing we did was condense. Second thing we did was rewrite as an exponential. And then now we're just going to finish the problem by solving and checking our answers. So we'll have 9 equals 3x. Nope, just kidding. Let's erase that. What's that going to be? 6x squared. 6x squared plus 3x. I'm going to set it equal to 0 and see if I can't factor. So I have 0 equals 6x squared plus 3x minus 9. I know what you're already saying on the other side of the screen. You were saying take out the GCF. I agree. 0 equals 2x squared plus x minus 3. And I hope you remember how to factor because it works. So 0 equals 3. We'll multiply to 2x squared. Yep, you're right. 2x and x. And then you got to figure out what's the right combination for 3, or negative 3 that is, so that when you do kind of FOIL it out, it would add to positive 1 on the inside. So this needs to be plus 3, and this needs to be minus 1. So that when you multiply the 2 times the negative 1, that'd be negative 2. And 3 times the 1x, that's going to be positive 3, which will add a positive 1 in the middle. So there it is. So when does this equal 0? That would be x equals negative 3 over 2. And that equals 0 at x equals 1. And I got to check my answers. Oh, good grief. It's off that page. So when I plug it in, if I put negative 3 over 2 right here, if I put negative 3 over 2 there, that would be some negative number, and you can't do the logarithm of a negative, so that is not going to work out for us. So we are going to cross that off. This one's no good. And remember, I'm not crossing it off because it is negative. I'm crossing it off because when I plug it into the original problem, it makes the inside of the logarithm negative, and so that's why I'm crossing it off. The 1 will work out, and we are okay. Have a great day.